of you. I'm going to simulate this example, distillation example, using HYSIS. Okay, so you can see the problem statement: stream coming out from Dethanizer and entering a Dethanizer. So Dethanizer means we are going to remove ethane. Okay, to recover ethane on the overhead. The inlet stream with below compositions and condition is pumped to 3700 kilopascal. So we had feed, so feed conditions given here, you can see. Okay, and then we need to pump it to higher pressure before it enters the de-ethanizer column. De-ethanizer column will be basically distillation column. Okay, the flux ratio is given to 0.5 and had to recover 99% of ethane. So we have two specification. One is reflux ratio, that is column component recovery in overhead. Okay, the top. Pressure condition is given. Okay, and of course we have all hydrocarbon, so we will be using Peng-Robinson. Okay, so first of all we need to construct a shortcut distillation to know the number of stages and optimum feed stage and so on. Okay, let's do it. So I will start from scratch. New file, add component what we have, sorry, we have CO2, ethane, propane, normal butane. So CO2, ethane, propane, okay, normal butane, normal pentane, normal hexane. Normal pentane, okay. So I have added all the components, all the hydrocarbon. So we'll use Peng-Robinson fluid package. Okay, and now we can enter simulation environment and we need to define the feed. Okay, feed, okay, temperature, pressure and molar flow rate. So 500 kilomole per hour, this is feed. Okay, and temperature is 23,000 kilopascal. Temperature is 20 and 3000 kilopascal. Molar flow rate is 500 kilomole per hour. 500. Okay, composition: CO2 0.01, ethane is 0.61, so this is mainly ethane, we need to remove it. Propane, butane, propane is 0.26, in 0.021. Okay, so feed is ready. Now all you can see that normally this is gases, isn't it? And one thing I want your attention here, it says that inlet stream composition and is pumped. Usually we pump liquid, isn't it? Okay, and if we need to increase the pressure of gases, we use compressor. So now it is pumped. So we need to see what is the feed state, where is the state of so temperature at 20, and this is very high pressure at 30 bar. So although all the gases, but at very high pressure it will be liquid. So vapor fraction is 0. Okay, so it is liquid. So this temperature pressure, always keep looking at these numbers. Okay, now we need to increase the pressure further. So what we need a pump. Okay, where I go, I need a pump. So inlet is the feed, outlet is the, we can say, distillation in. Okay, tube pump, and then what do we need? We need the pressure here. Pressure 3700 kilopascal, isn't it? So this is working 3700. Yep. Okay, so now this will go to the distillation column. Okay, so distillation column, shortcut, inlet is this one, condenser duty Q, condenser, distillate is D, reboiler duty Q, reboiler we can give the name, bottom is B, unknown key component. So external flux ratio is given, right? 2.5, and then okay, let me do this one, uh, full distillation column. Okay, this is the distillation column, 10 trays. So some information we need before we proceed for shortcut. So I will delete this shortcut right now. Okay, and then we can add a distillation column normal. Okay, distillation in, I said, the ethane. Okay, full reflux overhead product, reboiler duty, condenser duty. Okay, number of stages 10. By default it's 10. So you can see S10 and feed entering in 4. So feed entering here is 5, so we can change this to 4. Okay, what else is remaining? Bottom liquid, bottom. Okay, now next is visible. Okay, choose this one. Condenser pressure is same as feed pressure. Okay, so this is 3700 kilopascal. Reboiler pressure is 50 kPa higher. So 3750, right? Okay, next. This estimate it will calculate. We don't need to give. Next, reflux ratio given 2.5. Vapor rate not given, and we say done. Okay, and converged. And if you look at monitor, okay, and then this one is not given, right? This is not given. So reflux ratio is given. Now we can see degree of freedom is 1. What means that we need one more information, which is given as column component recovery. 99% of ethane is going in the overhead product. Okay, so what we need to add the spec. Add column component recovery, column component recovery, and stream overhead molar spec value 99, 99. So 0.99. Okay, component is ethane. Add it. Okay, now we go to monitor, and this one is added. So we need to make it active, and this is active, and that's it. This should run. And below the stage pressure, yeah, it's converged. Look at performance. Bottom 300, over 81, bottom 118, and composition. If you want to plot the composition, okay, or let's see. Okay, this one I will delete. Okay, let's see overhead. What do we have? Composition. Ethane. Ethane is there. Liquid of propane, because ethane and propane will have very close boiling point. Not very close, but close boiling point. Of course, higher element we don't have. Butane, pentane, all coming to the liquid bottom. So you can see we don't have CO2. CO2 is very light going all. Ethane is also, we don't have propane. We have, and we have butane. Okay. So this one is done. Separation is there. Now we need to see the profile, performance column profile. We can plot temperature V graph. Okay, so temperature keep increasing at each stage. Yeah, which should be the case. Okay, if temperature stays constant, it means that at those stages there is no separation. Okay, so we have like extra number of trays. Okay, and composition also you want to plot. So this one you can see butane, CO2, ethane. Ethane mainly we can see ethane. Ethane is green. So ethane you can see is decreasing, and stop. Like each stage there is some separation is going on. So this, if it stays constant, it means that we have extra number of stages. that we can try to see if suppose we increase the number of trays. Okay, let's see, we have 50 and convert, then we added too much maybe. Okay, 12. Let's see performance. Yeah, so now you can see this is coming constant. So if we add more, it will be, there is no separation. So that is extra number of trays or stages. So you don't need. So especially you are looking for whether your uh, decision column is well defined. Then you need to see for these things. Okay, 99% recovery ethane is received in performance tab. A smooth composition transition of ethane. No extra trays used.